Okay, everyone. Hello, everyone again. Hello, Claire. How are you doing today?
Hi, I'm doing really well, and it's a great honor to be here. Thank you.
Glad to see you again, and thanks for participating to this conference, and looking forward for attending this great session about refactoring. We had some discussions about it, so I'm really curious about it. And I leave you the stage to you. I'm behind the scenes, so anytime I can assist you with questions and anything. Thanks, Claire. See you afterwards.
Thanks very much. So, welcome everybody to my talk on refactoring superpowers. Can you see my slides? Yes, you can. Excellent. Yeah, so a warm welcome. This talk is about C++ IDEs and how they can help you do your work faster and more safely. Briefly about me, I've been programming in C++ and Qt or Qt for more than 20 years. My background is chemistry. I've done a lot of work in crystal structure visualization. In recent years, I've really been focusing on techniques and strategies for working with legacy code and hard to maintain code, predominantly as one of the two main authors of the C++ implementations of approval testing. But a lot of stuff about refactoring and legacy code techniques in general. You can contact me through Clare Macrae Consulting Limited, that email address, and my Twitter handle is on most of the slides as well. I'm always happy to have feedback afterwards and to chat. And if you want to talk about how you might apply these techniques in your work, very, very happy to chat about that, because I always learn from those kind of conversations. So I've got 3 goals for today. I want to inspire you to do 3 different types of things. I want you to explore the techniques that I'm talking about and to experiment with them. So to find out what's available, then to actually try them out, and then to practice them, because it's only with practicing them that you get to be proficient and able to use them without thinking about the mechanics. So what is refactoring? Well, it is about restructuring code. It's about improving the design of code that already exists. And it's really important that it's about keeping the behavior the same. So no fixing bugs along the way and no adding features. So if you find a bug when you're refactoring, make a note of it, have a separate conversation about it, find out if it really is a bug or an intended behavior. So refactoring uses the first 2 to help you do the last 2, basically. So it's an enabler. And in this talk, I'm going to be talking about micro refactorings, making tiny steps, individual small steps. So you make a small refactoring, preferably with your IDE doing the work for you. You review the change, you run your tests, and then you commit the code. If when you review the change you don't like it, then you revert the change. If the tests fail, then you revert the change. Otherwise, they pass and you commit and carry on. I talk in the title of the talk about making your changes more safely. And I want to talk about where that safety comes from. It comes from your IDE, its knowledge about the language that you're using, the tools it provides, its running of the compiler to detect errors as you type, as you work. It comes from your tests to ensure you haven't changed the behavior. Preferably automated tests, but sometimes you don't have those and you have to refactor to add them. So in the meantime, you run the code manually. And it comes from version control. And I want to be really clear here that as I make each of these micro commits, I am committing the change to version control as soon as I know that it's an improvement. Now, there's a separate conversation to be had about whether you squash those commits or not later. But as I'm doing the refactoring, I'm always saving each change so that I can back up a few steps. I can use the git bisect if I do accidentally introduce a problem. All those sort of standard good benefits of version control, you want them to give you safety as you go about refactoring. Now, why refactor? Well, I really love this quote from Kent Beck. He says, "For each desired change, make the change easy, which may be hard, and then make the easy change." So the idea here is if you need to make a change that your current design of code wasn't designed to do, then you rework the code so that it will become easy for you to implement the feature or fix the bug. If you haven't seen the Refactoring book by Martin Fowler, I really recommend it. It's got a lot of really useful information about lots of small micro refactoring techniques and how you can chain them together to use a small series of small refactorings in surprisingly powerful ways to make major changes. There is a free web catalogue, refactoring.com, of the refactorings in the book and some extra ones with minimal information and pictures. But that links to a full web edition of the book with all of the text from the book with lots of hyperlinks. So the book and the web edition are paid for things, basically, and the catalogue is free with good links backwards and forwards. So for any talk on refactoring, you really need some example code to work through. And the code I'm using today is code to represent the Sudoku number puzzle. If you haven't seen it, just quickly talk through the rules. So it's a number puzzle. You're given a grid with 81 cells in it, 9 by 9, with some numbers present already. And your task is to fill in all of the gaps, satisfying the constraints. So you have each digit appearing once per row, once per column, and once per 3 by 3 block. So that's it. That's the job. And I picked up this code from this 4-year-old webinar by JetBrains, where Zoran Horvat talks about a 1,000-line method and refactoring that to divide it up into cleaner code. And he did it without tests and by relying on the compiler to check his work. I wanted to try and see if I could get tests and an IDE to do more of the work for me. So he calls it the Sudoku Kata, the code, and it's coding practice demonstrating an awfully long method. And it's in C# and it's 1,000 lines long. Now, you may be thinking, but I wanted to see some C++ code. And so for a bit more context, I gave this talk originally in March at the ACCU conference without the specific focus on C++. And I used Zoran's used the C# code. I got some really helpful feedback on the talk through the conference organisers. Leveraging the IDE to do more of the grunt work is worth experimenting with. So that's great. They picked up that it's getting the IDE to do the tedious stuff. The C# tooling is much better than the C++ tooling. That's certainly true. And I want to explore, but here I want to explore what the state of C++ tooling is. And then finally, as a C++ programmer, her mostly C# talk did nothing for me. Now, once I mulled that over, I realized that's really useful feedback. These talks are general and they're about general techniques that you can use in any language if your IDE is good enough. So that tells me I didn't make that clear in the original talk. So that was helpful. But it also made me even more want to do a C++ version of this. So here we are. And so for this, I decided I would convert the C#. As a novice C# developer, I would convert C# code to C++. This 1,000 lines of C#. So first of all, I tried it manually and it was slow. By the time I'd got about 1/5 of it done, I'd got a bug that I just could not fix. So I gave up doing the manual approach and I tried out this tool called Tangible C# to C++ converter. So Windows desktop application, it has a free version where you can convert 100 lines at a time. And I got far enough with that to pay the $150 or so for a year's subscription to use the fully featured version. So I got it to convert all of my code, my tests, the library, to C++, and then I spent a few days fixing the code. And they're very clear that they don't do a complete conversion. It's a starting point, but a starting point that will save you time. So now I've got my 1,200 lines of C++ code, and it works and it behaves the same. So now back to the talk. Whenever I want to refactor code, I check if it's, whenever I work on code, I check if it's got tests. Now I'm going to spin very quickly through how I added tests to this code. So the first thing you do is you run the code to see what it does. And in this particular case, it's a console output that generates a full board, removes some digits to make a puzzle, and then step by step solves one digit at a time until usually at the end it gives you the original board back. Sometimes it fails partway through and you still have some missing digits. So that console output is really useful for writing tests. I can capture that and use it for regression tests. And in order to do that, I found that I needed to extract some parameters from the original code. I'm going to show you how I did that in CLion. So this is our first automated refactoring that we're using. So this code that you can see here on line 20, the original code has a play method, and it starts by declaring a random number generator and a stream to which it's going to write the output. So I found when I ran the program multiple times, I got different output, and I needed to make that stable. And so what I did was I right-clicked on RNG, the random number generator variable. I said, refactor this. And I said that I want to extract a parameter. That's option 7. And it asked me to confirm the type and the name of the parameter. And this is the change that it made to the header file. So on the left is the original code, and on the right, it added the include line and it added the parameter. So that's fine, that's great. And then this is the change to the matching CPP file, the implementation. Again, that's exactly what I wanted. For the calling code, it didn't know how to create the new value to pass in. So it left me with some code that is intentionally not compiling. And so I can compile the code and fix it and carry on. So I think this is a really important property when a refactoring tool can't do exactly what's needed, that it makes sure that you end up with a compilation failure so that you fix it. Now, this is a trivial example, and of course you could do this by hand, but many of these refactorings, they'll update many lines of calling code and save you lots and lots of time, as well as giving you safety. So I started off with what's on the left, and I ended up adding an OStream console argument and the random number generator. And this is what my test looked like. So it's a catch2 test. It should do the same thing twice. I create the console and I write a loop with 10 different seed values, create a random number generator with that seed, and call the play method. So I've got 10 lots of output in one stream, and then I ask approval tests to verify the output. I needed the 10 seeds to get me from 90% coverage with one seed to 100% coverage with all 10. If you haven't seen approval tests, then my talk from CLion gives you a lot of background about how to use them, and they're really powerful for adding tests to legacy code and hard to test code in general. Now, as you start to use refactoring, it's really easy to end up in this bottomless pit of keeping on making small changes and moving code around and tweaking names, but never actually getting on and really implementing the thing that you need to implement. And the way to avoid that refactoring bottomless pit is to know the purpose of the refactoring that you're doing. So is it a particular bug you're working towards, or more commonly, is it a particular feature that you're wanting to implement? And so for today, the feature that I want to implement is to solve puzzles set by others. So the bulk of the code is, right, now I've got a puzzle with some empty cells, try and fill in the gaps. And I want to change it so that I can reuse that code. Now, don't be tempted to read the code in the next slide. So this was the original code. And now the point of this is to show you the nesting and the indentation. That's pretty much all a single method. In the C#, it was 1,000 lines. In the C++, it ended up being 1,200 lines. And what do you do when the code is too long? You extract a method. Divide and conquer. And I'm going to look at doing that in ReSharper C++. ReSharper C++ is an add-on for Visual Studio. So it's Windows specific, Microsoft Windows specific. It does work in the free version of Visual Studio, but you do need a license to use ReSharper C++. So this is my first attempt at doing this extraction. So I've collapsed down the code so you can see these little signs indicating I've collapsed the code. And I've actually got more than 900 lines of code selected here. So I right click and say refactor this and extract method. And what you can see is that it's proposed a new name, do work. I'd probably rename that to what I want it to do, like solve puzzle or something like that. Or you could accept the name and improve it later on. And then it's recommended. It discovered that this long list of parameters needs to be passed in. So this is stuff that was created before the code that I'm refactoring out. So it needs to be passed in. Now, a really important step with any refactoring is to say, is this an improvement? And I could say, yes, I will accept this refactoring, and then I will make a later change to reduce the number of parameters being passed in. Or I may decide to cancel, which is what I'm going to do here, and say that's just too many parameters to pass in. And quite a few of them, all of those stacks, it turns out that they are created. So this is where they're used in the code that I'm extracting. And the first few lines of comments are quite significant. It basically says, this is a duplicate set of code because I couldn't exactly reuse the previous algorithm. And so that tells me that probably this data is independent. And I'm going to do an experiment now to test that out. If my tests pass, then I can move on. So I'm going to start by asking the IDE to surround the code that uses these stacks and the command with parentheses. So there's a refactoring to do that for me, surround with block. So I select that and it worked. Of course, that's just adding scope. That's not going to change anything. And then the next step I did was to give that block that I'd created its own copy of the variables. And in this step, you can see on the left-hand side was the original code. And on the right-hand side, I copied the direct declarations from the start and pasted them inside my new scope. And that compiled and that ran and the tests passed. So that told me that I hadn't changed the observable behavior of the code. Now, depending on how your IDE is set up, you might get a warning or a compiler error here about shadowing. We've got variables here, and there are variables with the same name in the outer scope. So I might have to rename these variables when I copy them in, or maybe I'd stick with the original refactoring and extract the method first and then deal with the duplicate variables. So all the time you're trying things, you're reviewing them, you're learning about the code and continuing to make small improvements. So now it should be possible to have our method extracted, but give us much simpler code. So I'm going to do it first of all in ReSharper C++. I've done the same thing, selected the same 900 lines of code, and now it's saying I only need these 5 parameters to be passed in. And the first 2 of them are the 2 that we'd already extracted to create the tests. So that immediately tells me that the only thing that's needed to solve a puzzle is these variables, board state and final state. That's really useful information. It would have taken a long time to sit down with a printout of the code and follow what got passed through 900 lines of code. And this is how you use refactoring tools to help you learn about code as well as improving it. And so I accepted that change. And on the left-hand side is highlighted in green are the additions that ReSharper C++ made to the program header. So it added some include lines and it added my new method, the declaration. And on the right-hand side is the change to the CPP file. And I'm showing you here the call to the new function. Now, it put the extracted method above the previous code. So it's a 900-line diff. And I'm not showing you all of that. So the code is identical, but it's reordered it. So keep that in mind. So the code compiled and the tests passed. So that's a big double thumbs up for this massive refactoring by ReSharper C++. Now let's try it in CLion. So CLion is a standalone C++ IDE. And I did the same thing. This is the refactor, the extract function dialog that it gave me. Pretty much the same as the previous one, but it required me to type in a name. And I like that. It makes me think about that. What did CLion do with the code? Well, for the header, the first thing to say is that what was before a std O stream has become a std basic O stream. I don't like that. That's the behavior is the same, but the code is less clear. But then worse, with the std vector, it's mangled the declaration. So this was a vector of vectors of char. In the CPP code, well, the first thing we see is that the call is not compiling. So big warning there. But it got the O stream right and it got the vector right. And so I was able to copy those 2 lines to the header. And then the code compiled and the test ran. And this is the sum total of the change in CLion. So it put the new code at the end, basically put a dividing line in. So it added the call and then the start of the implementation. So we get a cleaner commit history with this. So, and it sort of mangled, it deleted a new line that it didn't need to, but that was trivia to fix. So yeah, pretty good. It's almost there, not quite, but easy to work around. And then the third tool I tried out was Visual Assist. This is a different Visual Studio add-in that provides different refactoring capabilities. Some different, some the same as ReSharper C++ in Visual Studio. It's also a commercial tool. All of these are commercial tools. Unfortunately, it said cannot extract method. Now, I want to say at this point, although Visual Assist failed here, in preparing this talk and doing this refactoring in lots of different ways, I have found ways in which Visual Assist is better than the other 2. So it has refactoring capabilities such as encapsulate fields, and it adds getters and setters and adds calls that neither of the other 2 have. And for some of its refactorings, it has a richer set of options that give you more control than the other 2 JetBrains tools I was using. So it swings and roundabouts as to which to use. Now, I'm unusual in having 3 commercial tools here because I do this stuff a lot. And I would say to you, use the tool that you have, get familiar with that. If you decide that you need more capability and you want to go ahead and evaluate a commercial one, that's fine. But So I'm trying these different ones to show you the range of capabilities that are available. I'm not saying go out and buy all three. But in this particular case, that was a big no for Visual Assist. So just quickly to compare the ReSharper C++ and CLion dialogues that I showed you earlier. They basically have the same capability. They have subtly different ways of allowing you to reorder the parameters, change the name. CLion allows you to add new parameters if you want to, or you can do that as a later step. They differ in where they put references versus copying of parameters as well, but they basically do the same thing. Now, if you didn't have any of those tools, or you had a tool that it just didn't work, I want to show you a third option just for awareness, to let you know that it exists. But I'm not going to go through it in detail. And that's doing this manually and safely. And I want to introduce you to a technique and a GitHub repo called Provable Refactorings. So the GitHub repo is digdeeproots/Provable Refactorings. And it's a set of recipes for how to do the kind of things I've just shown you manually, incrementally, in tiny steps, each step the code compiles, and if it compiles, you know the refactoring is going to work. So it's really powerful stuff, so long as you follow the recipes to the letter. So, for example, it has in its core 6 recipes, extract function. And this literally does extract a free function. It has 9 steps, of which the 9th step is optional. And step 1 is to wrap the code that you want to extract in a lambda. So you put curly braces around it and either capture everything with no arguments passed in and just call the code, or if it returns something, then do the same thing but add a return statement. And if that compiles, you know you can carry on with the later steps. And it's something that when you practice the technique, you can get it working really quickly for you. So that refactoring that I showed you earlier with the 12 or so parameters, I reckon that would probably take me a couple of minutes to extract that, going through the recipe in detail. And most of that time will be adding the concrete types for all of the parameters, which is just it's just rote stuff. Okay, so that's enough about extracting method for now, but let's review where we were. So I showed you that the refactorings weren't necessarily what your end goal might be. And so I've ended up writing myself a little kind of checklist of, once the refactoring has worked and I've committed it, look at what I've got. And am I ready to go on to the next step? Now in C#, I didn't really need to do all these kind of things because the IDEs just basically got them right and how I wanted, or provided me enough control that I could state my preference before I did the refactoring. So with parameters, you definitely want to check whether you want references to be passed in or not. You want to see whether it's put the final code as public, protected, or private. You want to see if there's any places that you can add const, both in parameters and in making the method const. You want to also consider whether you might add no discard on the method, the value that you're returning, and you want to consider the order of the new code. Do you want to move the declaration up or down, for example? And you want to see if any clutter got added. So some of these tools create extra variables that are not needed, and you might want to inline and get rid of them. And CLion, bizarrely, with STL types, often adds this __1 clutter. So I've spent a lot of time removing those and thinking about it. I probably should create an automate in my IDE to get rid of those, just a global find and replace. So all of these things, I'm not trying to undermine the power of these IDEs. These are really powerful tools. But it turns out that the C# version, C++ versions of these tools, you have to do a little bit more thinking, a little bit more of reviewing, but they can still save you huge amounts of time. So I ended up so we saw that I ended up having a method call, which I ended up calling solve grid, I think. And it took these 3 vectors, board state and final state. And I could see there was a concept there that was hidden in the previous code, which I decided to call grid. I could have called it puzzle. So I extracted those things out into a class initially with public data. And so that's what you'll be doing as and when you need to modify code. It's a common thing with legacy code you want to refactor, that concepts are hidden in the code via variable names and things like that, but not necessarily represented by classes, data structures. And it turned out that that first thing, board, the vector of characters, what it was doing was it was duplicate data. So the state was the 81 digits, and then the board was the text representation of it. And it's good practice not to have duplicate data. So I used test-driven development to write a grid stringifier convert to string that took the board digits and ended up returning the string representation of it. And there was another location in the code where the digits were written out as this time as an 81-digit string, just 81 characters. And so I added to the behavior some behavior to the grid class to say, I can say grid dot to string to give me the nice picture of all of the digits, the grid, and grid dot to code to give me the simple representation. And so there we are. Now, remember that Kent Beck quote, for each desired change, make the change easy. Well, we're there now. I was ready. I got the bits and pieces. I was ready to write my test. So I've got an example puzzle from the internet. So my input, where the zeros represent the positions to solve, and the expected answer. And this has only one solution, which is important, it turns out, for this solving code. And I decided I wanted the test to look like grid, solve this input, and then give me it back as a code representation. And that didn't compile. It said grid.solve didn't work. And so I used a quick fix to say generate the solve method. And then I could work on it. And I ended up needing to write a new constructor for grid that took the string and converted it to digits. And then I ended up writing a solve, and this is how I implemented the solve method that my test calls directly. So I create the string stream, which I'm going to ignore the contents of, but that will be the console output. Don't care about in this case, so I'm just going to bin it. And I don't care about the seed for the random number generator, but I need to pass one in. So create a grid, call it input grid, call program solve puzzle, and then return the grid. And that is my testing. That's my feature implemented. Now, when I set out to implement that feature, I did not imagine it would be basically an extract method. I thought it would be a lot more complicated than that. So you won't always get that lucky, but these are the building blocks that will help you out. Now, then I went on to add further abstractions, so methods for setting cell positions and things like that. So that's a really important stage. Now, I want to talk about a few other techniques. I'm going to spin through them quickly in the time that I've got left. My other favourite Kent Beck quote for refactoring is, if you're ever stuck wondering what to clean up, move similar things together and different things further apart, and then you'll start to see the concepts and what's related. So, for example, if you had a class with lots of methods, you could rearrange the related things whose arguments are the same or who've got similar patterns in the method name. So a couple of tips about refactoring. When you're doing the right click and saying refactor this, it really matters whether the methods are static or not. So if you're refactoring static methods, you're going to extract fields that are static. And if so, it might be that when you start with static method, you might want to make it not static as a first instance, or add a not static, an instance method that maybe the static method calls if you need to keep the old interface. So that's a thing to be aware of. And you can do things like these tools will give you the ability to move code around, and you can use that moving to create new classes and to create files that don't exist as well. So there's all sorts of powerful things that just work. I've talked about making static methods non-static. This is something the C# tools do, but the C++ ones don't do. So you'd have to do that by hand. Okay, so I've only talked about a couple of different refactorings so far. So let's look at other ways that the IDEs can help you. The cursor location really matters. If you go to right click on some code and you expect to refactor and it doesn't work, look at where your cursor is. Move it to the variable name that you want to refactor. Move it to the bit that's giving you the error. If you've got red squiggle is saying this method doesn't exist, put the cursor in there and then you'll be able to generate the new method. And also many ways to access the refactoring tools. It might be in the main menu, it might be in an extensions menu. You might say, call up the whole list of refactorings, or my particular favorite is to say, refactor this thing that I've got selected or where the cursor is, because it narrows you down to show you the things it can do with that choice, with that selection. So I really like that. There are quick fixes, which I'm going to talk about, and there are generating code actions, which I'm going to talk about. So where this is where you've got a class, you've created a new class and no code exists, you can ask the IDE to create constructors, destructors, getters and setters, stream operators, all sorts of different things. If you inherited an abstract base class, you can make it generate the code for all of the pure virtual methods. It's brilliant. You can get the IDE to write new code for you as well by taking a selection and then saying surround with. So you can surround code with parentheses, that's option 6 that I showed you earlier, but you can make it, you can generate an if-else block, you can generate an if block, or an if-else block, all those sorts of things. It's really, really powerful. And you can write your own templates for this as well. So with the manual extracting via Lambda, you could add a surround with Lambda, step 1, surround with Lambda as a live template, and then just do it automatically. The reverse of that is unwrapping code. So I've got the wrong screenshot there. Sorry about that. So you can tell it to unwrap. Wow, I've got the wrong screenshot on the next one as well. Right, so unwrapping, if you've got code that's within a loop, within scope, or an if block, you'll have options to remove each of those layers. So for example, if I had a for loop that went from 0 to 10, and I decided actually I didn't want that, and I unwrapped it, I'd end up with some code that said int I equals 0, the start of the loop, and then the code that was inside the loop. So that can be really nice for rearranging code. And then with intentions, quick fixes, the IDEs tend to have ways that you can. So, for example, a thing that got added to CLion recently, if you've got a container class, so you've got a vector called stuff, if you write stuff.for, so vector doesn't have a for method, but if you write stuff.for, you're stating your intention to write a for loop that iterates over all of the elements of your vector stuff. And so if you accept the intention, it will expand that code for you. So all of these things save huge amounts of time and allow you to think what you want to do and just do it rather than writing out the mechanics. Throughout this, though, it's really important to say that I've been talking about a few IDEs, but I'm talking about your IDE. So for the language that you're using, languages differ in what capabilities they provide and how amenable they are to automated refactoring. And development tools differ. So really, I'm encouraging you to experiment and try things out and learn from that. So that's a whistle-stop tour of refactoring and other automated tools to do your work, do your refactoring. But what are the benefits of all of that? Well, you will be less tired at the end of the day or at the end of your feature, the end of this particular thing you're working on, because the IDE has done some of the heavy lifting for you. You'll be confident that the behavior is unchanged, but also you've left the code in a better position for the next person to work on it, which may be you or maybe a colleague. And the users are likely to get that feature sooner. I guess other things to say are you'll spend less time bug fixing along the way because you'll be confident that because the code is unchanged, you aren't going to have to spend ages in the debugger working out what you broke. Now, I talked about safety, but let's revisit that. So you can see how the IDE has given us safety by actually making the edits. Again, the tests are really important. If you don't have tests, refactoring the code safely enables you to add them. And again, I want to stress the importance of committing the changes as you go. So my call to action, my plea to you is to explore your IDE's auto fixes and refactoring features. Try them out. You'll be surprised at what they provide. I found things in writing this talk that I had no idea existed in tools I've used for years. However, this is really specifically to C++ developers. If you find bugs in the IDEs that you're using in the refactoring tools, please, please, please report them to the creators of the IDEs. Or if you find that a bug report exists already, please upvote it. I've seen feature requests and bug reports for some of these tools that are fundamental things, and the issues have existed for 5 years and only a handful of people have voted for them to be fixed. And so it's understandable that the tool makers are fixing other things instead, and request missing features as well. Practice refactoring difficult code to see what you can do with it and know how to use safe steps to transform your code. So that's my take home, and I want to say thank you very much indeed for your attention today, for coming along. Thanks to the organisers of the conference for inviting me to talk and for giving up their weekend to allow us to learn fun stuff about C++. We've got a few minutes, so I'm really happy to answer any questions or any comments that might have been made along the way.
Thanks, Claire, for this interesting discussion about refactoring. And yeah, we have a few questions on Remo. We'll get it through. One is about your library approval test, and someone is wondering if Catch has support for approval tests by default. I think it doesn't, but I leave you to you because
that's a good question. So approval tests is a layer of code that sits on top of existing test frameworks. And so it takes care of lovely things automatically, like you don't need to supply a name for the file that gets saved with your approved output. So it asks the test framework to supply the name of the test that you're running, and it uses that to generate nice file names. And the C++ implementation of approval tests works with Catch, DocTest, Google Test, Boost.ut, and Boost. I think I mentioned Boost and CPPU test as well. And if you're using a different test framework, it's really easy to add support for new test frameworks. I'd be really happy to work with anyone who wanted to add support for other frameworks. So it works with one framework. You use it with the current test framework that you're using.
And let me just mention that it's in Italian, but we had a meetup one month ago, and we had Yuri Valentini talking about this great library you crafted. So we have a talk about it in Italian. Obviously we have also your talks in English, but just for mentioning this.
Yeah,
we have another.
Kicking myself that I didn't add the link to that in this talk, and it's really exciting that other people are now sharing the news about approval tests.
We can insert the links to the video as well on YouTube. Yeah, absolutely. Okay, another one is something that I struggled with. It's not my question, but it's from someone who was asking something, was wondering something that I struggled with in the past. Is basically Visual Assist and ReSharper together. So what's your feeling about that? What's your experience about that?
Yeah. So in the past, I've used Visual Assist and ReSharper on multi-million line code bases, and the IDE never coped with having both of them enabled. And so there were times when I switched between one or the other. Both of them really impact the performance of the IDE, and there are support pages created by the makers of these tools that say, here is how to configure your IDE so that we don't kill its performance, we don't slow its performance down so much. For this talk, with only 1,000 lines of code running Visual Studio in a virtual machine, I found that if I had both of them enabled, it killed the performance of the IDE. So unfortunately, I think in my experience, you have to have one or the other enabled. And to toggle which is enabled, you have to restart the IDE. So my guess is most people will specialize in one or the other and not both.
Yeah, I agree with you. I experienced some performance issues as well in having both. So at the end, I opted just for going with one of them. And, but they are both valuable tools, definitely.
Yeah,
definitely.
And each has some really, really significant time-saving refactoring that the other one doesn't have. So you kind of, you pick your poison, basically.
Yeah. Okay, the next one is this one. Let me paste it here. Is from Marco. How do you start refactoring code with no tests? What if you need to test single functions one by one? This is a classical question.
Yeah. So there's two halves to that question, I guess. So first of all is, how do you start when you've got no tests? And I talk about that more in my CPPCon talk. That's really the goal of that talk. But basically, if you're really lucky, there are seams already, there are points in the code that you can call the function, create an object, test the behavior on it, and access that straight away for tests. That's fairly unusual, though, when code was not written with tests in the first place. So the writing of tests helps you to think about how to structure the code to make it easy to test. So if that's not possible, then you have to refactor the code one way or another to provide a way to get to the code that you want to test. And I tried to show how to use a safe refactoring to do that in this talk. But that's only a starting point. I can't, and the steps you make will be dependent on the code you're testing. If you don't have tests, then you can do things like add a huge amount of logging output, verbose output to the code, make it write out lots and lots of information temporarily, and then start doing manual refactorings, step-by-step refactorings, until you can. So you then run the program by hand and save the output. So sort of manual approval tests. So you've got lots of detailed log output. Then you start refactoring, and you keep, as you make changes, you keep running it, keep diffing the output, and eventually you get to the stage where you can write your first integration test, a test of a lump of code. And though that extra logging might only last a day, it might last half a day, it might last half an hour, but some way to get you some guarantee that you haven't broken it. And then, of course, you remove, assuming the logging isn't useful, you remove it at the end. But the second half of that question that I want to talk about is kind of a more philosophical one. And the second half is, what if you need to test single functions one by one? And I want to rephrase that question and encourage you to think, when you're writing tests, about try and avoid thinking about testing functions and try and think about testing behaviors instead. So I ended up writing a test that called program.solveboard. But I wasn't testing that function per se. I was testing the behavior of solving a board. And that means that if I change the implementation in the future, my test that I can solve the board is still valid. The inputs are the same, the outputs are the same. And the reason I'm saying that is because for all but the lowest level sort of algorithmic code, I suppose, if you write a test that says test function X, test my implementation, this part of my implementation, if you then refactor the code or someone comes up with a better technique, your tests are going to be brittle. You're going to have to rewrite all of your tests for the new implementation function. Whereas if you express your test in terms of the particular user visible behavior, they'll be much more useful over the long term. And again, that's the subject of a whole separate talk, but I think it's a really important thing to bear in mind. Don't think about testing implementation details. Don't test about thinking private stuff. Think about testing the behavior that's visible to users.
Oh, that's great. And let me just say that we had a talk about BDD by Yuri. So the same guy who gave the talk about approval tests, and that just an information for the attendee. Okay, last two questions. Then we go for a break, and Claire will be available for follow-ups in the networking. So the next one is, do you use a specific method to measure benefits from refactoring, sort of ROI? Because from manager's perspective, refactoring often sounds like developers' whim.
Mm. Yeah, so I think general advice I would give is that, so there are some lovely analogies around kitchens. I think this is from Emily Bache, I think. So think of refactoring as like doing the washing up after you've cooked a meal. So if you cook a meal and you don't do the washing up, you let it pile up, then the next time you cook a meal, you've got more clutter in the way, and there comes a point where you actually don't have the utensils to cook the next meal, and you have to do the washing up, and it's all dried on, and you have to soak it for ages before you can remove it. So it's really important. So this is a developer mindset. It's really important to think about refactoring as part of your normal work, and not refactoring for the sake of it, but making the changes that are needed for the business feature, the feature that your manager is asking for. And if you'll find over time, if you don't do that, that as you add more features, the code gets more complicated, and you're slower and slower and slower to provide new features. And somehow you need a way, if you're in that situation, to explain to managers that there's a reason why you're slowing down. Lots and lots of stuff on Twitter that I probably can't point you to immediately. So ask me on Twitter later, and I'll share some links of recent comments about that. But don't give in to the idea that you have to have a separate task on the board for refactoring. It's got to be part of making the feature that you're implementing.
Yeah, that makes sense. Okay, last one. Last one is from Yuri, the guy who gave the talk about approval tests.
Hi, Yuri.
Yeah, it's from Yuri. It's mostly about if you see idioms that are common between languages and also idioms that are specific for some languages. Idioms in terms of refactorings, obviously.
Yes. So a lot of the idioms that tools implement come from that refactoring book that I mentioned. And yes, there are ones that are in common across IDEs. So renaming symbols, for example, is the most basic one, and then extracting methods. But it turns out, so I can only speak about C# and Python versus C++ for the JetBrains tools, because they're the ones I've got the license to all the tools. So I think it's fair to say that C++ is a much harder language to deal with than C# and Python. So there are more ways you can accidentally break the code, and I'm sure that's a part of it. But there are many refactorings and fixes that are supported by these tools in other languages. So things like extract a field can be trivial in some IDEs and basically doesn't exist effectively. You can extract static fields in some of these, but some of these C++ IDEs, but extracting instance data members is generally not possible. So you can do a comparison of what's available between the languages and think they're similar, but when you look about the detail and the amount of control they provide you, uniformly there are fewer capabilities in the C++ tools than C# and Python. But that doesn't mean to say they're not valuable. They're still worth using and they'll still save you time, but you can still help improve things by encouraging the tool creators to do more.
Claire, if I can say just one comment about the idioms, I think probably one of the most valuable refactoring that you have in C++, not only C++, but it's kind of unique of C++ is adding const automatically. Many languages doesn't have the same concept of constness that we have in C++. And for example, ReSharper++ has this feature of adding const automatically. And so it figures out that you are not changing the variable or the object itself. And it basically proposes you to add const anywhere possible in the file, in the project, or in the solution. And that's, I think, it's a great thing.
That's really good to hear, because I was refactoring static stuff. I guess I didn't see that, so that's super powerful and really good to know. Thank you.
You're welcome. So thanks, Claire. Thanks a lot for the talk. I think we can follow up in the networking area. And now we have a lunch break, 30 minutes, and then we'll get back for the track A, and we have a talk about AI with Mattia and Eric. So thanks a lot, and enjoy the rest of the conference. See you around. Cheers.
Bye-bye.
Bye.